Let's solve another heat transfer problem, this one involving convection. A fan forces air over a computer circuit board with surface area of 70 square centimeters to avoid overheating. The air temperature is 300 degrees Kelvin, while the circuit board surface temperature is 340 degrees Kelvin. Using data from Table 2.1, determine the largest and smallest heat transfer rates in watts that might be encountered for this forced convection. So if we look in Table 2.1 under forced convection for gases, we'll see that the convective heat transfer coefficient varies anywhere from 25 to 250. So that's an order of magnitude difference. And that is not unusual to see for convective heat transfer rates. Convective heat transfer rates are determined experimentally, and depending on the details of the situation, the rate can vary considerably. So in this particular case, we have a range of 25 to 250, and those have units of watts per square meter degree Kelvin. So here's our given data. The temperature of the board is 340 Kelvin. The temperature of the air is 300 Kelvin. The area of the board is 70 centimeters squared. Well, we need that in meters squared. And there are 100 centimeters in a meter, and we have to square that conversion factor. That gives us a surface area of 0.0070 square meters. Now, the minimum heat transfer coefficient is 25, and the maximum is 250, both in degrees of watts per square meter Kelvin. The heat transfer equation for convection is that Q dot is equal to HA delta T, where H is the convective heat transfer coefficient, the area of the surface convecting heat, and the change in temperature, the difference in temperature between, in this case, the board and the air. So we can say that the minimum heat transfer rate is our minimum heat transfer coefficient, 25, times the area times delta T. And the maximum rate of heat transfer would be the maximum heat transfer coefficient times the same area times the same temperature difference. So we see that the Q dot minimum would be 7 watts and Q dot maximum would be 70 watts.